up to now, we have looked at resistors. Resistors have been our focus, and now we're going on to other components. Capacitors and also inductors are very common components used in electrical engineering, and they have different properties. Resistors have a property. For example, they're used as current limiters because the added resistance decreases the current. As an example, one of a few examples that resistors are used for. Capacitors also have their use, but what are they? They are essentially two plates. A capacitor is two plates of metal, and when the current flows in the capacitor, it charges. It builds charge, and that building of charge essentially makes a miniature battery. So first of all, we're going to look at how we treat capacitors and also inductors in a circuit by first looking at capacitance, because capacitance is trickier, capacitance in a parallel setup and also in a series setup. So in the top left, we have two capacitors in parallel. Excuse me. The two capacitor ends are attached to each other. That means that when the energy is flowing, the current is flowing, it is seeing an increase on that metal area. You've added more area to the two metal plates by adding in another capacitor in parallel. And because of that, the capacitance, overall capacitance, increases. So that's very different to how we've been looking at resistors. We have two resistors in parallel. There are more paths for the energy to flow. Because there are more paths for the energy to flow, the resistance essentially decreases. Here, that's not the case. You're increasing the metal area of the two plates, and therefore you're increasing the capacitance. Now for two capacitors in series, now what you're essentially doing is that you're adding in more gap between the plates. And because you're adding in more gap, more space between these two plates, you're decreasing the ability to charge. And because you're doing that, you're decreasing the capacitance. So it's very different to resistors, how we treat them in a circuit. Let's do a couple of examples. So here we have the questions from the workbook. The top left question, two capacitors in parallel. And this is very straightforward because it is essentially 3 plus 2. 3 microfarads, so capacitance is in farads. 3 microfarads plus 2 microfarads is 5 microfarads. Okay. Now looking at two capacitors in series. Now when they're in series, the capacitance decreases. So in this case, we treat it, how would we treat it if it was two resistors in parallel? And what that means is that we have the 3 microfarads multiplied, I'll do this, by the 6 microfarads divided by the addition, 3 microfarads plus, plus 6 microfarads. Okay. And that's going to equal 18 microfarads divided by 9 microfarads which equals 2 microfarads. That's the answer. 2 microfarads less. So on the left-hand side, the two capacitors in parallel, the capacitance increases. You add them, it's 5 microfarads. On the top right, the two capacitors in series, the capacitance decreases and becomes 2 microfarads. Okay, so what about inductors? Well, inductors also have different properties to resistors, but when they're in circuits such as this, you essentially treat them like you would treat resistors. Now the unit is henries, the H stands for henries. So here we have 1 microhenry and 5 microhenry. Now I told you what capacitors are, essentially two plates very close to each other of metal. What are inductors? You can think of inductors, because oftentimes this is what they are as big loops of wire. Many, many loops of wire. And what happens is when current goes through an inductor, when it starts to travel around the inductor, around the loop, it creates an electromagnetic energy. And that electromagnetic energy opposes the current. But for now, let's just concentrate on how we deal with them in a circuit, very similar to how you would deal with a resistor. So here we have two inductors in series with one another. So 1 microhenry plus 5 microhenry is 6 microhenry. Okay. And again, similar to a resistor, the bottom right, you have 3 microhenries in parallel with 1 microhenry. That's going to be 3 microhenry times 1 microhenry, which is 3 microhenries, divided by 3 microhenries plus 1 microhenry, which is 4 microhenry, and that will give us 0.75 microhenry, a reduction in inductance. I hope that makes sense. If it doesn't, contact me.